Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're going to talk about tube and profile laser cutting systems. So let's dive deep into it. Now first, you have to inherently understand the world run on metal parts. Duh, like that's a very basic thing to say and that's truth. You want to understand the health of a country, figure out how much steel they are making annually. That's how important it is. So be it pipes, tubes, square tubes, profile beam, whatever have you. These things are the backbone of the civilization that you and I take for granted, fundamentally. And you might be like, okay, what do we do with these things? Okay, these things are stock material. What the hell do you do? Well, you cut them to the length. Generally, that's the first step. You take a very long one, you cut it to small one. Step one. Step two, drill holes. Lot of them. Like for example, if you looked into Edison Motors or the individual that I interviewed about making a hybrid truck in India, trucks are big heavy trucks. I'm not talking like pickup trucks and all that. Big heavy, basically backbone of the country trucks. They are generally giant metal C-beams and you have a lot of holes into that. So generally you have a long C-beam supply, then you cut them and then you drill them. Drilling takes a lot of time. So fundamentally, and that's just the trucks part, truck industry, half of the industrial section is just taking beams and cutting them to the required length, nothing more than that. So you'd be shocked, like if you can have a machine that can do this, you'd be shocked how much industrial clients you're gonna get. Just like, hey, we have this material, cut it in this price, go. Oh, of course, have a lot of drilling holes and all that. So like short up, take money. So an architecture, railings, staircase, way too many things to name. It's just like all of the world behind the scene generally requires something like this, where you have the ability to cut a stock metal material and again, drill holes into them. And here's the deal. This is a core of a nation building ability. For example, I have recently linked a very interesting video from Jerry Rig Everything. He wanted to make a solar roof, so to say, for Speed Week, where they can charge their battery bank and the battery bank will run the administrative assembly vans or something like that. So in those sort of scenario, you needed a structure. How would that structure be made? Profile beams. You cut profile beams, you drill profile beam, you go home. And America is learning that it's an unwise idea to have that sort of machine in China. So they're like, yeah, let's bring everything back to America. And again, he's a wheelchair factory, literally runs on pipe laser cutting machine. So fundamentally, there are a lot of abilities you unlock if you can do this. Because now, do you need to have this? Yes and no. Can you do what this machine do manually? Of course, you can do it manually. But here's the deal. Money does not buy time. Money only buys speed. So for example, how quickly can your factory churn out a truck is directly proportional how quickly you can do material processing. So if material processing is like 1 hour versus 1 to 5 days, because again, trust me, drilling on those big C-beams take sweet time and a lot of sweat, blood and tears. So yeah, that versus shui, go. So that's like night and day difference. So fundamentally, it has the ability to build nations. Like you can do things that you may not think it's important, but it's like short of take money. For example, let's say you cut a pipe, right? And you want to give a 90-degree bend. What do we do generally? We slice those puppy at 45-degree angle and then you weld it. But again, that you have basically two parts and you have to trust the welding is perfect. But here's the deal. If you have laser cutting, you reduce that system. Why? Because you can have a curve and then you have a perfectly fitting place. So the 90-degree can be maintained far more reliably. Welding, the weld bead area goes down drastically. So trust-wise, you increase the trust while reducing the consumable item, so to say. There are many things. Like if you know what you are doing, you can do amazing things. Like if you want to make a roll cage, you need to cut a lot of knots. You can do it manually, but good luck. So there is a need for this. This is not a luxury thing. This is like, nah, you need it. So how does this work? Well, inherently it's just CNC with extra steps. So cutting element, generally you have two options. You have laser and plasma. Let this be very clear. Plasma you will rarely see, but plasma is there as an option if you are low on funds. The plasma is cheap, so then why don't people use it? Plasma gives a very messy edge, so you have to do grinding work after you have cut it. So it may be okay, but many times people is like, if I am spending that kind of money and I still have to do manual grinding just for cleaning, but I have to do that, it's like, wouldn't it be better to just like pay a little bit extra and go to laser where just like that step is removed? So plasma is like more of like DIY, more of like this edge niche case, it makes sense. Generally, you will not get it, but it is an option. Second, most likely, thankfully, development of fiber lasers have made laser a much better option. And you can have like ludicrously high power rating now. We've gone are the days where it's like 1 kilowatt, like, whoa. Like you can easily just go for 2 kilowatt or 3 kilowatt, like Meh, who cares? 5 to 6 is like, now we are talking 20 kilowatt. That's also available. So that's how the cutting element works. Now here's the cutting element has to move in 2 axes. So when you're talking about a pipe, you have to understand pipe is constrained, very well constrained. But again, it has independent profile. It could be circle, it could be square, it could be rectangle, it could be I-beam, it could be H-beam, whatever have you. Some companies were showcasing some weird geometry, which again, I'm like, why is that geometry even reused? But again, it's up to you. You are making a machine, you have to make sure that machine works with everything. So the laser head has to move in 2 axes, not only like this, but also like this. So it has to do that. And same technology is utilized in laser head as normal sheet metal cutting, where you can probe, either be inductively probe the surface or physically touch the surface to probe it, or some have some sort of optical system. You have to probe the surface because again, no matter how center or accurate this system, feedstock is never precisely ground. So it's a rough material, so you have to compensate for it. So cutting element gets 2D motion and tube motion, like how the heck the tube moves. Now tube, you will notice like this goes way too many back and forth. So tube motion is basically the main critical part. So you have to grip it without crushing it or damaging it, and you have to allow motion. That's the messy part. That is generally a messy part. And tail are generally clamped, because generally when you're talking industrial scale, the tubes could be long, like 12 feet long, or maybe even longer than that. So you can't just like pull, no motor will be like, bruh, I'm out. So generally there is a tail pusher that is doing the heavy lifting, so to say. Tail pusher is the one that is doing bulk of the work of physical movement, so to say. So, and again, if you don't do that, especially on long material, you can add a twist, like how you see long rebars. So rebar, you take a small section, it's like, GG. You take a very long section, it's like, ooh. So you will have something similar. And again, if you want to maintain precision, you do not want to add twist, camber, things of that nature to metal pipes. So it's like, hey, have something that is on the other end that is also syncing the rotation to the first end. And adjustable support is also required, especially for long one. If you are having a small puppy like 6 foot, who cares? But if you're dealing with 12 foot, ooh, you need that. But otherwise, the material will start to camber upwards. It's like, because of the mass there. So generally, these are support system, and support has to be designed in such a way that it folds out of the way when the tail stalk moves there. So it's not that black and white, so to say. It's complex. But again, there are some designs I've seen where you pull the material out, but it's very rare. I would not bet money on that you're gonna see that. It's very rare. It's like to pull the material. I've seen lathe machines that have something like that, but not in laser system. But somebody, I think, copy pasted that design here. But in most scenario, you generally have tail stalk that is doing the pushing and pulling. So that's the working. It's basically your laser moves in 2 axis minimum, and then you have this rotation mechanism that allows fully free movement, and that movement is achieved by tail stalk. Tail stalk is also rotating in sync. And you need support depending on the length. Most of the time you do need it, especially if you are working with thin wall material. Now here's the deal. Fundamentally, we are not talking about something more complex than a CNC machine, but the core essence is the chuck. This puppy. Basically, where your money goes, this puppy consumes your money. So chuck is the way where, think about it, it's like it has to clamp the material in 2 axes. Basically, it cannot go left to right or top to bottom. So it's like, nah, I lock you here, you are locked here. So that's there. And it has to maintain freedom in 1 axis. So lock in 2 axis and have full freedom in 1 axis. Like, yo. That's why you generally see rollers. It has to be rollers. Otherwise, like, how the heck you're going to move it back and forth? So that's there. And it's fully indexed. So meaning the rotation of this is not just like it spins with a motor. It's not that. It has to be like, okay, 15 degree plus, minus 20 degree, plus 20 degree, plus 7 degree. It has to be like that. So it's indexed. And I do not mean incremental encoder. It's like a fully absolute encoder is utilized. So you know how the heck it's moving and spinning. So it's a difficult test. Let's just be very clear. It's a very difficult, very finicky thing, and the tail stalk has to sync up with it. For example, if this puppy is going YOLO, the tail stalk also has to go YOLO. In sync, it has to be perfectly in sync. Otherwise, it will end up twisting. So fundamentally, doing that. And syncing, now thankfully we have developed servo motors. Thankfully servo motors have encoders. So nowadays syncing 2 rotating parts, even though they could be very far apart, like 12 feet or 30 feet, is not a big deal nowadays. It can be done. Now head chuck is the main tricky part. With how the heck you clamp it? Well, if you have a very simple system, like very cheap down system is only designed for round tube or square feedstock, they could have like linear motion where it just clamps in all axes at the same time. Not recommended because you can't clamp rectangular things. So I will link a video down below where an individual builds a like iris kind of structure where it clamps onto a round stock. Round stock, awesome. Not suitable for rectangular stock. So rectangular stock, you generally have two axes. So, and if you want to see this axis in motion, look into your printer. Most printer have a paper tray. In this paper tray, you will find clamps that are on the side. But if you move one clamp, the other clamp moves automatically. So that same mechanism is used. It's what we call self-centering chuck. So you generally have pneumatic tube pushing the chuck, and because generally we are dealing with metal, the moment you clamp, you get some resistance, clamp stops there. And that's how you have two independent axes. So it automatically fits itself. Or if you want to save money, instead of getting pneumatic, you can have manual system where you just go every time you have to do that, you do that. Again, only recommended for low throughput system, but if it's a high throughput machine, that won't be manual, it will be automated. But you can do quite amazing things nowadays. So generally this will spin like there is no tomorrow if all you are doing is like taking a long stock material and cutting in small section. Then that spinning material will be as fast as your laser. So if your laser is like, I got this, motor would be like, I got this. So motor could spin like almost 100 RPM. Generally not done, but it can be done if your laser is able to keep up. So that's the chuck part. So most of the engineering goes into the chuck, basically making it stable, making it reliable, making it trustworthy. So, and you can build it yourself also. I have linked a video down below. So let's understand the machine part of it, the pro part. Basically, if you want to buy it, these are expensive. Let that be very clear. If you look into sheet metal laser cutting, multiply the price by 3 or 4, then you'll get that. Now, like, wait a minute, is it really that expensive? No, its demand is less. Not even demand is less, people want it. It's just that supply demand has not balanced up perfectly, so it's very expensive compared to the CNC system. So many companies will give you, you have this laser CNC, you can have an add-on of pipe cutter. Exact same thing that basically Jerry Rig is doing for its wheelchair factory. Because again, the hardware is the same. As long as you can figure out the chuck mechanism, everything else is shut up, take money, it's easy. So that is there. Now, more automation you want on these puppies, the more expensive they will be. Meaning if you want, hey, I have just this material coming in and then the final process part goes out the other end, yeah, it will be expensive. For example, you may not think about it, but what happens to the material once you cut it? What mechanism do you have to handle it? Well, for example, this, you see this tray is automated. It actually pulls it out, pulls it away. So based on the material you are dealing with, based on how much human intervention you want there, some designs would be like, you do not touch it. The person drops the material in one slot, like almost like with a forklift, and you go home, like done. The final part would be literally final part. So in those sort of scenarios, you have to spend a lot of money in automation. Now, is it worth to spend that much? Well, it depends on what is the human labor cost. And most companies are realizing that it's better to have automation than to have human labor, simply because running cost piles up. These machines are expensive, but again, they are industrial equipment. They can easily last 10 years, easily. And their ROI could be as quick as 3 to 4 years. So most people are like, yeah, just pay that extra thing. And again, that creates a compound error where it's like, okay, now machines are expensive. So people are like, why not add a little bit more money? Why not add this automation? The overall cost becomes even more crazy. So capital wise, this is expensive puppy. And again, they are huge also. Let that be very clear. In terms of land footprint, how much you need, this thing will make every other machine look small. Like these are huge machines. And God help you if you're dealing industrial scale materials. So fundamentally, these are huge. So the more automation you want, the more costly they will be. And cutting power generally comes in two core categories. You have less than 3 kilowatt. They are generally classified as mid-range to mild power. And then you have god tier power, 6 kilowatt or above. That's industrial grade. Basically, at that point in time, you're processing material. It's like, okay, 20-foot container or 40-foot container is coming in. It's all the raw material is coming out. Go. So that is at that level. Now, basic 2-axis cutting that you see, it's not that expensive. You can get it done without too much hassle. That Jerry Rig one is basic one. Like, what is the complex one? Complex is bevel cut. Now, do you need bevel cut? If you're welding, yes. That's like short up technique. Like same way people do not want to deal with plasma because you have to do grinding stage. Bevel takes up one step above. Basically, you never want to weld metals like this. Like you do not want like, that's not what you want. You generally want a groove here and a bevel here, so you can have weld puddle there, properly reliable. So imagine the material cutting itself gives you that. So if you can rotate the laser, you will get that bevel cut angle. But again, it does add one extra axis. And again, computer software also has to become complicated. But again, we are not in 1990. That's like, shut up, take money. It's like, bro, even Raspberry Pi is like, I can do this in my sleep. So figuring out that angle from tool path, that's easy. But welding, like imagine you have to weld a pipe there. Super easy. You just put it there, done, go. So fundamentally, that the moment you add that axis, it becomes what we call add-on. But again, they are expensive. But if you have to do welding, people will be like, shut up, take money. It's like, it does not make sense to not buy that. If you have to do welding, having the ability to get the precise angle on the cutting floor, shut up, take money. But they are expensive. Let that be very clear. It is expensive having this whole system. It is expensive. Now, what about do it yourself? Well, thankfully, because it's a very important tool for many tasks, even a small workshop. There are more than enough scenarios where a small workshop would be like, we would really love to have this. So in those sort of scenario, some people have come up with clever ideas. My personal favorite is this clever idea. It's like many places have what we call plasma tables, basically a CNC machine that has plasma cutter, but it's a 2D machine. So they're like, okay, what if we have a pipe there and let it roll and it just rotates? They did it. It's very clever. It's like, it's one of the most clever thing. But again, your length would be limited, how reliable it would be limited. But if you are not dealing with very long stock, this is surprisingly clever, and you can make bicycles out of it in mass, or like you can do roll cages in mass with this sort of thing. So you convert your plasma table into this, link to video down below. And then you have somebody who was going like, he was dealing with roll cage, so he was like, okay, what if I make it directly? And this machine is kind of independent rather than like a big machine. It has just like, okay, this is the material, it pulls the pipes. It's assuming the pipes are not very long. But again, more than good enough for what he is doing, and it is using plasma. These two are plasma systems. Again, the system does have open wiring, so wiring wise it's like, but again, cheap and good, gets the job done, shut up, take money. For many college projects, it will be like, it would be actually better to make this machine, then start to work on roll cage. And then there is this guy. I have no idea what is wrong with his brain, but he was like, okay, what if I make the whole machine? And yes, he actually machined that damn thing. Yes, the chuck is made by him, not bought. He made it. I'm like, and he made the full system, full, like, it's not like, okay, management or jugaad. It's like, no, full thing. He made the whole machine with a tailstock, with a rotating system, with a whole chuck system. And the idea was, which was very clever, it's like, if you are buying in civilian use, 6 foot is the stock material, because generally 6 foot is super easy to ship. If you want longer material, of course you can get it. It's just that shipping will be ludicrously expensive. So they're like, hey, what if I can make a machine that is made for that home use scenario? And of course, let that be okay, he's not that smart where he's building like a Tony Stark arc reactor and making fiber laser. But you can buy fiber lasers nowadays quite cheaply, surprisingly cheaply, in contrast to other things. But he's like, okay, what if I make everything else? This is good. This is horrifying, but this is good. It can be done. So it is a very useful addition to most metal working shop. Let that be very clear. In most scenarios, like, shut up, do this. Most scenarios are like, shut up, do this. And if you already have the materials for laser, some people have figured out how to have this as an add-on to their pre-existing laser system. Like how you have a laser cutter and you can have a spin axis, similar thing. So it's a really, what we call, clever utilization. This one, super fine-tuned for one task, super awesome. This management, just like reutilizing your plasma table for Mote. And this guy went all out. It's like, hey, if you are running a college and university, just have few people working together and ta-da, we have this tool, ta-da. Oh, current project includes making a 3D metal printing. So there are a lot of DIY options. Let that be very clear. Never let someone stop you from trying to do this. You can do it. Even some of them sell you plans also. So it's not that difficult. So this was my presentation on basically metal pipe, basically laser pipe cutting tools, hopefully. And I hope you liked it, learn from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.